welcome back to my channel. Good to see you again. So, in this video, we are going to talk about AWS Lambda. So, what does the AWS? Let's see what we will what are the talking points. So, we'll first of all see what is AWS Lambda. Then, what are the key concepts involved? Then we'll see the things that you should keep in mind while using AWS Lambda. We'll discuss some pros and cons. Then we'll see some real life use cases where you can actually use it in your real world. So let's get started. So what is AWS Lambda? So a standard definition would be AWS Lambda is a serverless computing service provided by AWS that allows developer to run code in response to events without the need of managing server. This server operates on function as a service model, right? And it enables user to focus on writing code while AWS handles the underlying infrastructure of running that piece of code and everything around it, like scaling, infrastructure monitoring, and everything. Just you just need to write your code and get it on the AWS Lambda. But so in this definition, in this there were many terms which has a very vast concept. uh, Let me highlight that for you, like serverless computing. I said that in response to the event, Lambda does all that in response to some events. So what is the events, how does that event happen, and how does Lambda responds to that event, right? The third thing was function as a service, right? So these are very vast concept in itself, and that needs to be understood very deeply to understand what Lambda actually is. These are the prerequisites, and then we'll talk about these prerequisite first. So first talking about serverless computing, then we'll see what is event driven execution. We also see what is function as a service, and we'll see what is auto scaling, right? So serverless computing is a cloud computing model that allows developers to build and run application without managing server or infrastructure. So you just need to write the code, deploy it on the cloud provider, and that has responsibility to manage all the infrastructure. And this model abstract away the server management task from developers and DevOps team of the organization, and or the server management team, right? Basically, DevOps is still needed to get it on the AWS infra, and just manual monitoring is also required, and many things regarding that. But you don't need to physically manage the infrastructure. Where are your servers? What is the operating system in that? Everything is working fine or not? The physical things and the OS level things and all. So that is completely abstracted away from the developers, and they just have to focus on writing code. And what happens in serverless computing is there is something called on-demand resource allocation, which means serverless architecture allocate resources basically on the dynamically usage, right? So developers are only charged for the compute time and the resources that are being consumed during the code execution. So the resources will be allocated dynamically as much as you need them, and the cost will also be according to them. So this provides an obvious advantage over having a dedicated infra which is running all the time, and even if there is no request, the server is just sitting idle. So that is like more costly as compared to the serverless infrastructure. So now some more features about the serverless infrastructure is auto scaling. So serverless infrastructure provides you auto scaling mechanism where you can scale up and down in response to the demand, and we don't need any manual intervention for that. That will happen automatically, allowing the application to respond effectively to the dynamic workload and the number of requests. And Another thing is event driven execution, that serverless functions are typically invoked by events such as your HTTP API calls or database update or file upload on S3 or somewhere. So this are the event driven nature, which allows for responsive applications that react in the real time to the user actions. So now the strategies and algorithm for auto scaling can be varied across the different cloud service provider, but auto scaling is vital for any serverless computing model, and that has to be there in any of the serverless computing model. Now I want to talk about event driven architecture and event driven computing in detail. So it's a kind of a programming model that focus on responding to events as they occur, which allows application to react in the real time to changes in the state. What does the state is? First of all, the event is defined as the change in the state of the system. So if a user interacts on UI, like he clicks somewhere, or he does, or he uploads a file somewhere, or something he does, which is user action with the system. And there can be also system generated signals, like you might have heard about event bridge, or basically a cron job which runs after every 30 minutes. The system will run itself automatically. So these are the event system generated signals. So these all are the changes in the state, and that's called event. So in response to the event, some action has to be occur, right? So this model enables application to process these event dynamically, and as like as opposed to the waiting for data to accumulate in the batch processing system, like how it does. So in event driven architecture, you have three components. So first is event producer, which generates the event based on the changes in the state. There are event routers that are known as brokers, because they filter and route the event from producers to the consumer. Finally, the third is consumer, right? These are the services or application that will listen and respond to the event. In event driven architecture, it promotes loosely coupling between the services. So your producer and consumer don't need to know about each other implementation details. They only adhere to the event format, right? So this will generate events. The broker will take the event, also known as event router, and consumer has to take that input, give the output. And yeah, this decoupling makes it easier to scale, update, and deploy service independently, right? You just want to change the producer, you just want to change the consumer, or you may want to change the routers in between. So that can be done independently. The next thing I want to talk about is a function as a service model. So what is function as a service? So function as a service is something that comes under serverless computing again, and that allows developer to run applications as an individual function which do not need any management of infrastructure. The key feature over here is the modularity of the function, because the functions in this function as a service model are very small and modular unit of code which is designed to perform some specific task, right? And this modularity allows developer to build application using microservices architecture, where each function can be developed and deployed and scaled independently. So you have multiple functions and they are deployed independently, and you can scale them independently, right? So yeah, based on the work, sometimes there is more workload on one function, where other function doesn't need to be that much workload is not there, so that doesn't need to be scaled. So that is provides us loosely coupling environment, where a small functions are separated as infrastructure, which can be developed, deployed, and scaled independently. Now, talking about some of the more key features of all the AWS Lambda, we talked about event-driven execution, but the the triggers are event. In case of Lambda, it get triggered by event, like we talked about key API request ho gaya, your data upload in the database, or file upload in S3. So these are events which can trigger your Lambda, and this allow for highly responsive application which reacts in a real time. We talked about auto scaling also. So Lambda may auto scaling is done based on the number of incoming requests. This means that it can handle varying workload, and you can serve, let's say, 1,000 requests per second without any manual intervention. Uh, the next thing is pay as you go pricing. So what does this mean? Users only pay for compute time consumed during the execution of the code. There is no charge where code is not running, making it cost effectively for many applications. That's why we prefer it over the continuously running servers like ECS. That has their own pros and cons. Lambda has that its own pros and cons. You just need to see whether you want to switch to a serverless model, or you want a dedicated server running up all the time. And one more thing, that Lambda is providing all the supporting all the programming languages, like you can code in Python, Node, Java, C++, anything, right? AWS provides support for so almost all programming languages. So one thing is built-in fault tolerance. Lambda maintains compute capacity across multiple availability zones, so that ensures the high reliability and availability. Even if the even in case of failures, individual some if one machine is affected or one data center is affected, that will not impact your system. So now let's talk about the pros and cons of the AWS Lambda. So first is no server management. User don't need to manage any kind of server. High availability, built-in features to ensure the applications remain available even during high traffic period or any failure in a data center or machine. And cost efficiency, because you are using pay as you go model, and you will only be charged for the compute that you have used. So that is why it is very much cost efficient. And let's talk about cons. What are the disadvantages? First and foremost, very big disadvantages: code start latency. So this is a latency when functions are invoked after idle timeout, like a prolonged idle timeout of maybe 45 minutes to 60 minutes. After that, when you invoke the function, it takes time to invoke that function, and that's called a cold start. That's a bit detailed topic. We may cover it in another video, because auto scaling in Lambda can also be covered in that video, like, say, we can make it fit in there. But moving on, so limited control over infrastructure. You don't have any control over infrastructure in AWS Lambda, because it's managed by the AWS only. Execution time limit. So this is another very much disadvantage in the AWS Lambda, because it's a function as a service model, and function are performing some specific task. So it is assumed that function will not run forever, and it will have some small time limit. So that function needs to be executed within this time frame. So generally it's about I think maximum time limit it allows us 15 minutes. So if a function takes more than 15 minutes, you cannot have it as AWS Lambda. You need a and you have to switch to any other service, right? So that is some of the disadvantages. And now let's see some real life use cases. So Lambda is used in various tasks and applications. So um, let's say your web applications, you can integrate Lambda functions into your web application based on you perform some you are performing some task on ECS, some task you can perform on Lambda. That's how you can integrate it with your web service. And it can be used as data processing, because Lambda function, as you know, triggers by events like upload in database, or upload in S3, or data upload in the database. So whenever you have some new incoming data, you can just trigger the Lambda for it. That's why it is more feasible to use it in data processing. IoT application, maybe we can use Lambda, and streaming processing, like services like Amazon Kinesis for real-time data streaming. There also you can integrate Lambda with it. So that was all. Thank you guys. Bye.